Now, today we will discuss how we can do PID control in Delta PLC. According to our project, we are using Delta PLC and Kinko HMI. We want to simulate and we want to check how the PID control in Delta PLC is working and how we want to make PID controlling and how is the parameters and how we can change and adjust the PID parameters. For the PID controlling by the company, by the Delta company, we have one instruction, and about how we can control and how the register we want to make for the PID controlling is all is in this instruction, PDF instruction. So also we will discuss a little bit about the theory, how the PID controlling is working, so according to our instruction. Here in Delta PLC, actually we have this this module. We have if we want just we want just make this is our PID control module. So in Delta PLC we have two kind of PID, 16 bits and 32 bits. We want to just use and 16-bit PID control, and how the register is working in PID control in 16 bits we will discuss now here. Here we have we have 4 parameters here. For example, D0, D1, how is in according to our topics, D100 and D150. S1 looks mnemonic schematic in Delta PLC. We have S1, S2, S3, and D. S1 this is our set value. So S2 this is a present value. So present value this is according to your actually sensor, because in PID control actually this is a closed loop controlling, and S3 this is a parameter. So important thing, this is a S3 because in 16 bits register this we have 20 parameters. So we have 20 register to adjust to our PID controlling, and this 20 bits now you can look here. There is one table from the S3 we want to start. S3 was this is the PID parameters. So S3 now we can check from the S3 and S3 to S3 plus 19 register. That one is automatically belong to your PID controlling. When you are using for example D100, from the D100 to D119 automatically belong to your PID controlling. You cannot use this register to another area. First parameter S3, this first one, this is a sampling time. This is a sampling time. This one, this is a sampling time. This is the time of sampling for your PID controlling. After in simulation, we will talk more about this one. What is this time? So how after how many times you want to one time adjust your for example adjust or maybe accumulate your output value. So this is belong to the time of this one. This your PID control belong to this S3 sampling time, and unit is 10 milliseconds. And now for example here I want I start from the D550 from this one we will start. So this is in our project. This is D550. From the 550 we will start, and 550 plus 1. So this one is 551 becoming another one. Now this is the P parameter. So you can look here. This is a proportional gain. So we know about, if you don't know about the PID control, there in PID control we have 3 important parameters. So this is P, I, and D. So P is proportional, E is integral, and the D is derivative. So your controlling system, you can say 19% belong to this parameter. So 100% belonging to this parameter, because according to our adjusting in these 3 parameters, so you can take so PID control. And first one is P. So now we will say here. This is now you can check. This is by the percent. So you need to check by the percent. How many percent you want to give to these P parameters. For example, when I give the set value, this is according to your set value. How many percent you want to go to this when that one is doing the controlling, and how many percent you can go to near to your for example set value, and between the set value, this is you can say here is saying, so this is the proportional value of the error between set value and present value. So difference between to the set value and how many is remaining from the present value to your set value. Another parameter, this is the integral gain. In PID control, when you are using the P parameter, so for example, you can come just near to your set value, and in some time, according to your process, this coming to, for example, on off, if you're using on off system, when you are coming to your set value, so sometime according to the process, you cannot find this a very good controlling in this time, so near to your set value. For this one, integral is coming to help your P parameters to become near to your set value. And another one is, this is also by the percent, so we will discuss. Actually, this is this percent of here. You can say this is your. We have another one is this is minimum and maximum integral value. So from here, from this S3 plus 8 and S3 plus 9, so you can change, you can set your integral value. So this is in simulation, we will see how it's working. So another one was the derivative. So derivative, what we have also D parameters and also the time. Here is derivative time is constant according to our Delta PLC. So this is the time you can see here from the minus 3, 30, 100 and to plus 1300 milliseconds. And also this one is percent in this one. So these 3 parameter was important, P and I and D. Another parameter S3 plus 4. This is the control mode. Which mode you want to use? In 16-bit we have 8 modes. We have 8 kind of the controlling, you can say, in this one. First, if you put this S3 plus 4, if it's 0, so according to this number 0, 1, 2 to 8, if you put 0 0 value, so your controlling mode is belong to the automatic. So what automatic? You can say both forward and reverse controlling. So in forward control, the error value is differentiation between set value and present value. But in the reverse value, this one is reversing difference between to the present value and set value. But in automatic mode, this is together, and you have forward controlling and reverse controlling together. Number 3, what is this? This is the automatically mode. This one is which we can just use in temperature controlling because this one when you put in automatically, this is same to auto tune mode we have in temperature controllers. When the controller first time going to 0 after to 100 controlling, and when that one is founding automatically P and I and D parameters, and after when that one is taking all these parameters in for example P, I and D, after that one is going to this 4, this one automatically, this one is going to the 4 mode, control moding of number 4. So in number 4, this one is the temperature control was using here is saying not available in the 16-bit instruction. So we don't have this these two kind. I think we don't have in 16 bits. Just one time we will check if we have or not. Now you can check here. We don't have that one in. Also, I think 6, 7, and 8 we don't have in 16 bits controlling. Now number 5. This is number 5. This is automatic mode. So this one now in automatic mode looks how it's working. This one is automatic mode. If output, this MV was the output of our controlling. For example, you can say analog output from the PLC. If MV reach the upper or lower limit, so the accumulation in controlling, so integral value will be stopping. When that one is going to near of your MV value, so accumulating becoming after stopping. This method just same to, you can say same to the counter, how to counting going to near of your MV value, output value after stopping counting. So accumulation here is value. MV value also we have accumulation also we have, and also we can give the MV value. So user can set MV value themselves and also accumulate it. Also we have by the PID controlling. But in manual control mode too, so number 8, output value, for example, output what is the MV value? Just again I want to explain you what is the MV value. MV value you can say how explain you. Set value, this is our value. Present value, this is your input sensor, and MV value, this is output. Which one, what you are connecting in the output, the analog output in your PLC. For example, if you have temperature control there, so you can use you are using SSR, or if you are using some another analog controlling, for example actuators or another thing, so that is your MV value there. S3 plus 5, this is the error, so which sent to the did band. So we have in temperature controller some value, so that one is not affecting us in controlling. So in near to this value, so in range of this value, so controlling is doing nothing, just staying. And S3 plus 6, this is the maximum output. For example, if I have 16 bits output, for example, my analog output signal is 3200, so I mean so integer value, so this is becoming 16 bit. You can adjust this maximum value. Now you can see here is the range, but this one is according to you controlling some area. Maybe when you want to just control by some range, you can adjust this range by the minimum and the maximum. For example, if you convert to the percent, you can say you want just between to the 20 and 50, for example, percent you want to control, and you need to adjust these two parameters. So how many values. So out in simulation we will see how this one is working. And about the integer value, we say this is minimum and maximum value. This both belong to the I parameter, so integral parameters. So this is a cumulative integral value. So we have two kind of one was automatic and another one was number 6 and the number 7. Number 7 was manual mode. This accumulated value, you can say we can adjust here in this parameter. So this is also these two parameters, previous value. This is the previous value. When you starting the previous value from that one is starting to controlling. This all to 20 parameter belong just to the S3, so PID parameters. So when you are making, if you can say all your controlling process belong to this parameter. So if you are making a very good setting to these parameters, you have a very good controlling in your PID controlling. Now we can go to the PLC and how we want to set this parameter and how we will control the by the PID. According to our project, just what do we have here? According to our project, we have so communication error. We have just 1 second. Because I don't connect my PLC. And we will check again. Okay, now I have EH3, so my PLC is transistor kind because I'm also using for the heating control transistor outputs, and I'm using EH3. And now here, so this one I will explain you later. Just about the parameters. I talk also about this one. I start from the D550 50. So from this one my setting is starting, and 20 register automatically belong to my PID control parameters. When you are using some, for example, if you are using register of 499, but you are using, you need to be careful. Maybe you are using that register in 16 bits. So if you know about the Delta PLC programming, if you are using 16 to 2 words, that one is belong to the 2 register. After your setting as becoming confusing and your PID control is not working clear. For this one, it's better you need to move all the PID control parameters a little bit far from your another registers. I start here number first parameter was the sampling time TS. So this one from me, this is 550. Second one was P parameter. Third one was I parameter, and another one was D parameter. So I don't have here all of the parameter, but what I need I have here. After we have the control mode, another one was the error, and also we have maximum output value, so MV, and we have minimum output, and maximum integral value, and minimum integral value. This is the PID parameters, PID blocks. So you can see we have these PID blocks. If for example I go to the help, what we have here in the help, just nothing, we just have a very small about this one, and also another things I just want to explain to you about this is now I'm using ISPSoft. If you are using WPLSoft, so in there also we have just a little bit difficult, not too much difficult, but little bit confusing things to controlling, to adjusting the PID parameters. Now here we have the PID. This is a PID. About how you making wizard, you need to go to the wizard and PID instruction. Now all parameter is here. Just you can see sampling time, all that parameter we have here. If you are using for the heating system, you want to use GPWM controlling, so with pulse, so you need to place this parameter. So after I will explain you how it's working this one. Okay, now we go to ISPSoft and we discuss another of our parameters. So what we have in PID blocks, so we have one thing was the sampling time. This one was first one was set value according to our topic, what we have there. S1 was a set value. Now you can check here. S1 was a set value. So from me, this is a set value. So now you can check here. This is a set value, and S2 was present value. So here I am connecting 4 to 20 milliampere pressure switch. This is my input value, and another one was the PID parameters. Now you can see here another two register, set value and present value. I'm using another register, but parameters I just start from the 550 because this in Delta PLC what I have here, this from the 500 I have a retentive register. So when the power also shut down, you can say we can say that one Z value cleaning. So this means of the retentive registers. So now you can see it's from the 500 from me starting, because one time I just adjusting the PID parameter after is staying, so we no need always to change. And I also have another memory I'm using here for the default value when you are starting your PID controlling, when you are for example run your PLC, your parameter is not adjusting automatically. So first you need to give some value to your PID parameters, and I'm using this one. And is better when you, for example, this one, when the PLC is running, or when we don't using the PID control, you need to make zero your output. Otherwise, for example, if you are using actuator, for example, so that one is giving some before you have some value. for the opening, so that one is remaining, and when you starting your PLC, that one is continuing by that way. Now here this D was so output, my output, that one was the MV, what I tell you about the MV. This is my output. I'm using D105, and what I have here, just this one finish for the controlling. I have 4 to 20 milliamperes input, and I have also 4 to 20 milliampere output. From this is pressure switch, and this one is actuator. Now we go to the Kinko HMI, and also now I will simulate by the Kinko HMI, just how we want to do. Just one time, what we have now here. Just about the selection. This one is finish. We have PID parameters. Now you can see here important parameter I have here. This is my vacuum controlling, so I'm controlling one vacuum in this here, for example here. Now this is my vacuum, and switch on. Steam, this is the steam, and this is my actuator here. So I'm using for the heating, I'm using this actuator to open and close the steam, and I will control of the temperature of this vacuum. So here now we have here in PID parameter I have all parameters. Now we will discuss about the PID parameter, how that one is setting. First parameter was the sampling time. That was the scanning time of your parameters, what you are giving to PID, and controlling in your control loops. Now another things what we have there. Okay, now about topic after. Now here we will start from here. Okay. Now this was the sampling time. I just put this is 1 second. It was 10 milliseconds. So if I put in 10, so that one is becoming I think 1 milliseconds. 1 second. And P parameter. Now first time I will put my P parameter 100. Okay, just this is maximum of this one is maximum output value, MV value. This is a minimum MV value. And first I'm using the auto mode. So first one was the automatic mode. And I have one memory to give the default value for it. First time I will give the default value to my PLC. Now I go to the control, and we will see parameters, how is adjusting there. We can see from the our PLC. We go to online simulation. Okay. Now this is my parameter, just I and D 0 now, and integral value also completely. Okay, just now my input of my present value. So by the sensor I just switch off from here because I just want to give myself the value. I just make open, and we will after we will connect. Okay, now we can put like this. Okay. Now I will open the Steam. Now look, the present value from me is 0. What is the P parameter? Now P parameter we just put 100. And we go to P, now we put the P parameter 100. Okay, now we are in the automatic mode. Now you can see our MV value, output value is same to our set value. For example, my set value was 32. This one was a 16 bit. Now this is belong to your control. If you are using the temperature controlling, or maybe you are using the pressure control. Actually, I'm using here the pressure control, and this one maybe after I will scaling to the 0 to 10 bar. So just for the clear understanding, I just put this value. Now you can see our output value is same to our set value, because we don't have any present value. Now differentiation between you can say differentiation between to the set value and present value, so becoming to the set value. Now I will put 100. Now you can see it's becoming to if you make differentiation, if you want to make differentiation, for example 32,000 minus 100. Now this is becoming, now this is our MV value. What is the P parameters meaning? So this is a but this also belong to the, that one was the percent. Now we can check another. Now I will put not 100, so this is a 100%. I will put 50%. 50%. After we go, we will check what is this one. Now you can see here is our MV value is completely changed. So now we have another value. What is this one is means? What is this one? Differentiation. Now we found differentiation. Looks now this is our differentiation between two the set value and present value. If I multiply by this one, if I multiply by this one to 15%, so what I have here, this is this value, our MV value. And also according to our topics, you can check, you can see here, this is just belong to the 0, 1, 2, and 3 and 5. And what is this one? This was the control mode. This just belong to our, if we go to parameters, PID parameters, we can check number 0, automatic, forward, reverse, and so just auto tune mode. This is just we can say this is just belong to the fourth kind of mode controlling. And now just we are using this one P parameter. So multiplying our P value to the what this is, E means E by T. So here we can what is here is this is the error. What is the error? You can see here is error is different between to the set value and present value. Okay, this was a P setting. Now I will adjust what I want. Again we will adjust to the 10%. So you understand. For example, I will put 10%. Now you can see our MV value is 3,100. What is 3,100? We can say now I will. This was our differentiation was 331,000. If I multiply by the 10%, what we get in this. Now you can see this is completely same. And this is important also. You can also adjust from this range now here. So we don't we have a very big range. So now you can check by 0 to 30,000% you can adjust. Now if I adjust to more than 100, what is happening? You can see now I will put 150%. Now because I don't have, okay, I will, it's better one time I make for example 10. This is my present value. Also little bit more, because it's a little bit more difficult to understand. I just put 110%. Okay. Now if my present value is 100, what is happening? Maybe more. I put 100. I have just 1000. If I 10,000, what is now? Now here is clear. We can check now. This value coming from where? Now we want to found what is happening. 32,000. This is a differentiation by 10,000. This is our differentiation A T. Now multiply by 110%. Now what we have, this is our value. This is clear for how a P parameter is, what P parameter is meaning. So this one is here. Now we will go to the another parameter. So that one is I parameter. What is I parameter? So I will explain how is what is in PID control when you cannot controlling by the P parameter. So you need to help of the I parameter. So now I will adjust is better in maximum value of this one. What is my maximum integral value? I will put not 32,000. I will put another value, so more understanding. So for example 100. Okay, because I parameter just percent of this value. How is adding to this one? Now I will put for example 100% say P parameter, and I will adjust I parameter to, this is also 10%. This one also percent, so I will put 10%. Okay. Now I will see 10% of this my value. Now this one I will change to, for example, to 0. Understanding? Okay. Now 10% of 100. What is 100? 10% is 100. Now you can see how is adjusting in PID control. What we have in output. So now we have in output 22,100. This value coming from where is coming. Now we can change what we have there. I will see. Now we have 100. So now we have 100 in P parameter and 10% in I parameters. Okay, just because I don't have, we will found 32,000. This is a set value. Differentiation, what is we have, this is the present value. Now we have this differential. and we have multiple by what we have right there 100%. Oh, sorry, this one. Okay, PID parameters, I parameters, and 100. Okay, if set value was again, now we have 32,000 in set value minus sorry, minus 10,000. So this is our present value here. So this is our present value. 10,000. What is becoming now? 10,000. Okay, we have 22,000, and what we have here is 22,100. From where it's coming to 100? According to our topic, so in our formula, here you can see your P parameter. So that one is adding after you have add here plus to your I parameter. So what you have in I parameters? So here in our I parameters we have maximum value of our integral parameters. So integral value was 100, and we put there for the setting, we put in parameter we put 10%. So what is the 10% of the 100? So now we need to remind this one 22,000, and now 100 is 10%. So 1,000 10% is 100 plus, and what we have there. So was differential was this one. Now you can see this is now we have these parameters, and this value completely 22,100 in MV. So according to our minimum and maximum, now I will change another parameter. I will change, for example, if I put here 100, for example, if I put 100, okay, now what we have there, we need to we should be have 23,000. Okay, now we have 23,000 because if you add this one, if you add differential was 22,000, if 100% of our integral value was 1,000. Okay, now we have 23,000. This is I parameters. And another D parameter. So D parameter you can just understand in temperature controlling. So here a little bit difficult to explain. But if you don't find your PID controlling in these two parameters, so P and I parameters, you need to also help in D parameters. So D parameters also need helping to you to come to this set value. But sometimes if you are using the D parameter, so you're controlling of too much confusing and little bit difficult to understand what is your values there. Okay, now what we have, we want to just think, we want to just explain how another parameter what we have there. Now we have control model. So here I just put in one list. We have 8 mode. We have in 16 bits PID parameters. we have 8 modes. Now we have, see here, 8 mode we have. First was automatic, and another, second was forward, and third was reverse. After we have auto tune, temperature control, automatic, and manual 1 and manual 2. Now what we have in reverse, what is how is our controlling in reverse in PID parameters. So now we can check if I put reverse. If I put reverse, so okay, another things. But, now you can see control mode now become 2, value becoming 2. Now we can just switch on our input sensor according to our sensor, how we can control. Now one time I need to go there in automatic mode. Just I will change the input signal. I will change input signal, and first we will put 0 for I parameters, and control mode I will put automatic. Okay. I need to go there in manual, and now you can see here when I'm changing the present value, this is our input signal, so our output MV value always directly come changing. What is the time of the changing? This is belong to this. Now you can, if I want to change a little bit late, I just adjust give time. Now you can check. I'm changing my input signal, but after few times my MV value is changing. Differentiation after is calculating. This name was sampling time. This TS parameter was this one, the time of the sampling, scanning of your parameters. I will put one sequence. Now you can change. If I decrease my input signal, now it's becoming minus. You can see here. This is my differential. So in MV value. Also another parameter what we have there. This was the maximum value of your output MV value. If I decrease to this one to 20,000, so this is belong to your scaling. For example, if I put 20,000, I just have this value. So you can see if I put our present value near to 1,000, you cannot come out. That one don't give you more than your maximum output value, maximum MV value, because you just changing your range, your output range, and for this one you need to, for example, in here when I'm controlling the pressure, maybe just I'm controlling by maybe from the 20% to 70%. So I'm not controlling from the 0 to 100% of open and closing this control valve, and for this one we need to adjust your minimum and the maximum MV value. I will put again 632, and now we will change. Into reverse. What is happening in our Now we can see here we have 0 because if I increase, why we have 0? In P parameters 100, if I put 20, 10%, nothing is happening. Why? Can do like this because differentiation should be less. Differentiation, we have differentiation here. If I put here 100, now we have, because you remember what we say about the reversing control. So that one is reverse differentiation between the present value and set value. Actually, when we are using so that number integral number, so here it will be difficult to understand how they're calculating this number because it's confusing to understand. But for more important things, when you are using this number, so how to understand that one is better. Now you can say differentiation between to this one and this one is here. So this is our MB value, output value. Now you can say when I decrease present value, my output value also is decreasing. When I increase my present value, my output MV value also is increasing. Now if I put 100, now you can see too much. Now it's 200 because here in PID parameter I put just 10%. I need to put 100. Now you can see here what I have. Now here differentiation, you can see here differentiation between two these. If I put 1000 here, so this one. And we say about we talk about the automatic mode was all and forward and reverse control. In after tune mode, so in after tune mode, we say about that one is just using in temperature control. When you are using the temperature controlling, you need to use this GPWM. So what is GPWM? This is a pulse width mode. So in there, just what you have in output in the here, what we have in our output. So in MV value, I means. So what we have in MV value, just you need to convert this MV value to the pulse because we are using in the temperature control, you are using the SSR. For that one, you need to use GWPM. And these two control mode also just you need to put just in temperature controlling mode. And now who use you can see here in GPWM T0. First one is when you are using in temperature control, this is our output. So this one is our MV. So here is our MV outputs. And the 20 there we have cycling of GPWM. When you are going to the wizard and to which parameter. So now looks okay, no problem. Now here what we have here output width. So this is D0 output cycle. What we have there output, this is Z1 is D20, and our output device what they have just this is our output. So if you are using memory, or if you are using so output, so there is using Y0. Okay, about two more another mode. So what they have 5, 7 and 8. 5 was just accumulating. Now we can use it on no problem. Just we need our simulation is finished. Just we can go again to the our simulation. Now if we put in accumulating mode, how to tune this one. Okay, here we go. We will see. Set value we need to change to, for example, I put 20,000. Okay, now you can see how the value is accumulating. Now looks is by self is accumulating when you come your present value, when you your present value this one PV coming going to near of the set value after stopping. Now you can see is accumulating, adding the value to there, so that belong to your accumulating value in the parameters of in these parameters. So in this one, take reference. Now when I come, now looks when I come to slowly when going to my set value, increasing and decreasing my MV value by self. Looks now becomes 0. Here we don't have any P and I parameters. Now you can say just accumulating. But when that one is little bit now, when that one is little bit low more than your set value, now looks is slowly increasing in accumulating time. And another parameter what was that one was manual one. In manual one you have also output manual, you can adjust, and also automatically accumulating. But if you put in manual 2, you don't have any PI and D parameter. You just you are just setting your MV value. Now when I go here, if I change, now you can say here now you can see here when I'm changing my this one, this is was my set value, present value looks present value when it's changing, nothing is happening in MV value. Now in MV value I just adjust what I want, I can adjust here, so nothing is happening, so we don't have any PID controlling there. Okay, this was okay. This was all about PID controlling in Delta PLC, and we just simulating by the Kinko HMI. Another things I just want to show you one thing more about how maybe easily to understand. I just want to put this percent one time. For example, present value, this one, my present value I just simulating by a 0, what I have there, pressure was 0 to 10 bar. Maybe just like this, 2 and 1 point. Okay, and set value also I just making that one same to how the scaling is going. This is belong to your HMI also 10 bars, so my input and output value is 10 bars. and I will just show you how is better simulation. My MV I just putting 3 integer and 1 point, so I just want to show this percent 100%. Okay, compile. And simulate. Now looks what we have in set value. For example, this is 6.3 bar. So I just put in 5 bar. If I put 10 bars, so we have this 32,000. My input also you can say here is 7.8 bar. My output is percent is 3.1 here. This one is 3.1. When I'm changing now you can see here we was in manual mode. Just we go to automatic and we will see this percent. Now my output is 72.8% is opening my MV value. When I put now you can see here, if I make 0, now looks what is the present value. My present value is 0.1. If I decrease, now you can see here 99.5% my output is open, and my set value is 10 bar. If I put 3 bar, for example, now I have just 29.5%. Yes, thank you. This was all about the PID parameter and PID controlling in the Delta PLC, and how that one is simulating and how is setting the parameters. So I was with you, and about the topics, so instructions. So you can just find from our telegrams. So all about the another details. So if you have another question, so you can give us in our telegram. So just I will write you our telegrams. This one is our telegram, so PLC Tajik. You can give any question about the PID control. So maybe if you need this program, I will send you the software and the PID controlling by the ISPSoft, the code of programming. Okay, thank you. Khuda Hafiz.